Hey, what's up everybody? In this video, I want to explore how well a fluid simulator such as RealFlow is able to adhere to the contours of a container when that fluid is pressurized. So what I have here is three parts. I have what I call the syringe, which is basically a funky syringe with some shapes coming out. And let me just isolate that so I can show you what it looks like on the inside. Okay, and I have here the plunger, which is already pre-keyframed, okay? And on the inside, I have what I call the jelly, all right? So we are going to explore this and see what it looks like in the end, all right? After this. We are back. Okay, so let's check this out. First off, I just want to point out that the jelly, and I call this the jelly, and reason being is because I'm actually going to add some high viscosity to the fluid inside the syringe in order for me to be able to better to see how well it's going to hug the corners of my shape over here. Okay, and it has a little conical component here just to kind of fill that space in. All right, so here we go. First off, what I'm going to do is I'm going to go to the RealFlow Maya tab here, and I am going to right click this button over here and select emitter fill. All right, and under the body, I'm going to right click that and I'm going to set the body to the jelly, okay, under the emission. So that's going to be the jelly shape, and I'm going to set that. Okay, so that's that. Right, so what happened? Where's the where are the particles? Okay, well, if we just kind of reset the scene to the beginning here, we should be able to see an array of dots coming up. I hope so. Actually, let me just not okay, there we go. All right, so you see those array of dots in there. Okay, all right, so let me just hide the female here real quick, the syringe. Okay, all right, so first off, one of the things that you can do to see how accurately these particles are shaped to the original over here is by adding a collider to the object. So I'm going to select the object here, and I'm going to press this collider button, and it's going to add a collider underneath. Okay, so with this collider highlighted, if you go down to the display, okay, under collider shape, interaction, wet map, display, there's a show collision geometry over here. So if I click that and reset the scene, it should be able to show me, you know, how well it's shaped to the original. And for our intents and purposes, it's good enough. I mean, I'm not going to go too crazy about it. You guys may notice that if I highlight the jelly here, under RealFlow Maya tab, okay, you might notice that by default your cell size is going to be on auto, and you might not like how it looks. But if you toggle off the auto cell size and set a lower number, you will see that the particles will be a little bit closer to the original. Okay, so now what we want to do now is actually for this fluid piece here, we want to actually shut off the collider itself. So first off, I'm going to undo the show collision geometry, but I'm going to scroll to the top and make the simulation mode inactive. Right now, what we are going to do is define colliders for the plunger and the syringe itself. Okay, so let me go ahead and first off hide the jelly shape over here, so I only have the particles, the fluid, right? And I'm going to bring back the syringe over here, and I'm going to define it as a collider by doing so. Okay, and again, because I've been playing around with this before, what's going to happen is I'm going to show the collision geometry off the collider, then I'm going to highlight the syringe, and already my cell size is set to 3, which is a happy place for me, and I'm going to reset that scene in order to show you. So you can see that it's pretty close to the original here. One of the things to note is that the collision is going to sort of define itself by the polygon shape itself unsmoothed. Okay, so if you need to have like more of a smoothed out shape, for your collider, you're just going to have to add more geometry to it. Okay, so regardless of whether or not your polygon is smooth or not, this is what it's going to take on. All right, so okay, I'm going to turn off the show collision geometry, and in this simulation the collider does remain active. Okay, and I'm going to do the same for the plunger over here, and I'm going to add the collider. And again, if I go to the plunger itself, I can see that under RealFlow Maya volume, the cell size is set to 3 as opposed to the default, which is auto cell size. So next up, I'm going to go into the fluid, and I want to define this as a viscous fluid because, mind you, I want this to have some sort of viscosity so that I have it's more easily to visually inspect how well this fluid is going to stick to the corners of the syringe body. All right, so I'm going to define viscous over here. I'm not going to make the viscosity too high. I'm probably just going to bring it down to 0.35. Okay, and this is mostly because I had played around with this the scene but prior to making this video. Okay, I'm sure most of you are going to start out at a viscosity of 1, and then you can always dial it down as need be. Okay. The resolution here is basically going to define how accurate or how well detailed your simulation is going to be. 2 is rather low in my opinion. I typically start off at 5. Okay, and there's one more thing that we have to do here is if we go into scene 1, there is a substeps that I like to override. And basically what this means is that as the plunger is pushing and pressurizing these particles, most likely because of the thickness of the wall, some of the particles are going to go off, they're going to skip past the walls, and they're basically just going to fly into eternity. Okay, and that's going to tax your CPU. So there are 2 things happening. First, you don't want rogue particles to sort of jump out. And the second thing is we're going to define a K volume later, which is sort of a kill plane for RealFlow, where any particles that go beyond that boundary are not computed anymore. Okay, so first off, what I'm going to do here is I'm going to uncheck auto parameters, and I'm going to increase the substeps, okay, or the calculation of particle travel in smaller bits, so that they are not going to move past these walls within a single frame here. Okay, so here I'm going to go from 2 to 10, and I'm going to go max substeps also 10. So it's going to be sort of an absolute number. Iterations, I'm going to go for 60 and 60. Okay, so that's what I'm going to do. I'm not going to go into details on these parts just yet on this video. This is more, again, just to see how well RealFlow performs, okay, under these conditions. All right, so next up, let's go into putting up the K volume, and I'm going to right-click these sort of 3 arrow icon over here, and I'm going to put up the K volume. All right. And let's just increase that in size. Okay, length and height over here. Bring that in. Okay, and let's just take a look to see, make sure it's well defined within the bounds over here. It's containing the any rogue particles whatsoever. Okay, great. Okay, I think we are pretty much ready to go. Again, I have this plunger already keyframed. And the final thing is we have to make sure that we define a proper folder for where caching the simulation will go. When I click my scene 1 over here, I'm just going to define my viscous under cache 2. Okay. All right, very good. So I am going to now run the cache, and this is going to take a little while, so we'll come back after this. All right, so here we go. I'm going to click this first, and I'll be back. Okay, guys, we are back. Here is what the simulation had given me. I'm just going to play this through real quick. All right. Okay, so as you can see, there have been some particles, rogue particles that had escaped the shell, and I would suppose that the best way to address that in future iterations of the simulation is to increase the amount of substeps, which again it goes under the scene 1, and I would perhaps increase the minimum substeps as well as the max, of course. And perhaps the iterations. Now, again, I'm not going to go into the details on what those mean and what kind of numbers you should put in, as I am also admittedly kind of learning the RealFlow as much as you guys probably are since you're watching this video. All right. So, okay. Well, let's just say that with all things considered, let's just say that this is sort of performing to my satisfactory level. Okay, with a decent amount of pressure, it seems like it's hugging the object really well. Now, so let's take a look and see what that looks as a render, right? So the first thing we got to do here is I'm going to go to the first frame. I have my fluid once object here selected, and I am going to basically turn that into a mesh by clicking this button. Actually, I think I'm supposed to click this button over here first. So I'm going to do that first. Okay, and it created a mesher. Okay, and I think that now what I have to do is run a I have to sort of cache the mesh. So I'm going to do that right now. Okay, so it's going through the whole thing and it's probably generating the mesh out of these particles. Okay, I'm going to go back to the beginning over here, and there is my mesh. All right, cool. Let me just kind of click around. All right, I got it. Okay, so let's see what it looks like, right? Here it is. Okay, whoa. All right, kind of bumpy here, man. What's going on? Well, maybe what had happened was one of the things that I did not touch upon with the particles, and this is really mostly just to save time on the simulation process, is to increase the resolution some more. I had a resolution of 5. I could have gone up. And now this is where I have to start to explore, how I can best reduce all these little jaggedy edges on my final mesh. Okay, so, but I'm just going to keep moving on here. What I'm going to do is I'm going to hide now the fluid, the emitter. I'm just going to keep the mesh here. It seems to be looking okay. And here are the rogue pieces that are the little droplets that have like escaped the confinement of the syringe itself. Seems a little pretty sharp over here at the end. Okay, I'm going to assign a material and let's render this out and see what happens. I have here a turquoise shader. Okay, let me just hide that as well, and let's just render the beginning first. Okay, so I'm going to do that. Oh, hold on a second. Let me first turn on my light. I just have a dome light that I'm going to turn on here. Let's bring that in and see what that looks like. All right, so as you can see, it's a little funky here on the texture, right? It's a little weird, but let's just kind of run down the line here and see what happens when let's just say the plunger is sort of like now starting to push and push the material into those cavities. Okay, I'm going to hide that. Let's see what that looks like. Okay. So we're kind of beginning to see what happens when RealFlow is interacting with the collider itself, right? it's we know for a fact that the plunger, the flat end of the plunger is in fact flat. However, there are little bumps being generated off of the simulation with these particular settings. Okay, so let me just keep going, and let me push it down to a point where, and notice also there are some bumps kind of forming over here. I wish it wouldn't, but that's just the way things are. Okay, so around the 51st frame here, I'm going to render that out for you so you can take a look at and see what that looks like. Okay, all right. So it looks pretty smooth over here. I'm pretty surprised at how that's turning out. But you know, again, there are these little like jaggedy edges here. It's not something that I would want to deliver to a client. You know, this is not something that is up to my standards personally, unless it's just a rough draft, you know, that the client wants to see. Let me try doing something now. What I want to try doing is perhaps reducing the amount of these polygons and then smoothing the polygon itself to see what happens. So what I'm going to do is I'm going to go into my mesh, and I'm going to reduce this by 50%. Okay, so I'm going to reduce that. Okay, and it's going to kind of bring down the amount of sort of details, right? Average things out a little bit. Okay, and I'm going to visually inspect to see what's happening here when this happens, when the jelly here, it's put under stress. Okay, that's happening. All right, maybe I'd like to do that again. Let's see what happens if I were to reduce it by yet again another 50%. I'm going to press G here to repeat the last command, and it's going to reduce it even more. Okay, so that's what it looks like, and with this amount of polygons, I am going to perhaps smooth it. Okay, so Maya's telling me that's still too many to smooth, so let me just do it one more time. Okay. All right, so there you go. Let me try to smooth this out. Okay, so there you go. So that's what it's looking like right now. Doesn't seem like it's really done a whole lot of a better job. Let me render this out for you so you can take a look at it. Okay, mind you, this is like even lighting, so perhaps the lighting itself is obscuring a lot of the imperfections on the surface. Okay, perhaps this is a trick that you can try implementing on your project if need be. I kind of like the fact that by smoothing it out, it has reduced the amount of that sort of ring that was being formed by the plunger pushing into the jelly itself. As you can see, there is this sort of the angles from the collision object, you know, which I stated in the beginning. If you want to reduce that, you sort of have to increase the amount of polygons. And yeah, I mean, the conical part doesn't look that great. Let me just kind of do it at the very ends here and see what it looks like. All right, so I'm going to push it to the end here. Okay. So this is under high pressure conditions, and we'll see what that looks like. Okay, so it seems to sort of clean itself up a bit under high pressure conditions. Okay, so this is where you know, perhaps the pressure of the volume has reached a certain amount of threshold, which really kind of nicely filled out the inside the cavity itself. I can kind of see that. It looks pretty nice here. Let me see what it looks like underneath the plunger. You see this ring over here? I still don't really like that too much. So let me render it like this so we can see both here and here what it looks like. Okay, it looks pretty clean. But again, this is even lighting, all right? If you had like some sort of a backlight or maybe a hard light skimming through the surface, you might see more of that imperfection. Thus begins our quest to sort of, find the right setting for RealFlow to behave well under these conditions. I'm going to try another video later on just to see if there's any way we can really use RealFlow in a way that's going to be presentable as a final product. All right. Well, thank you. If you have any comments, if you have any additional knowledge that you would like to impart, please do comment below. Please do hit like, subscribe, and I will see you on the next video.